Well, hello everyone. This is us moving on to section 4.4, and we're going to be looking at the laws of logs. So the first thing we're going to start with is called the 3 laws of logs. Now, how do you, if you can, combine logs? Well, there are 3 rules. The first rule says that the log of A plus the log of B is the same number as the log of A times B. The second law of logs says the log of A subtract the log of B is the same number as the single log of A divided by B. And the third one says that n times the log of A is the same thing as the single log of A to the power of n. Now, though I'm using log, which indicates log to base 10, this is also true for log to base 2, 72, log to base E, log to base 1.1. These 3 rules, laws, hold true as long as the bases for each are the same base. So these could be log 3, this would have to be log 3, and this could be log 10, this would have to be log 10. So that's our first thing. So how can that help us? Well, let's give you some other properties that are not part of the laws of logs, but are very useful nonetheless. The log of 1 is 0, regardless of the base. The log to base 10 of 1 is 0, the log to base E of 1 is 0, the log to base of 42 of 1 is also 0. 1/2 the log of A is the same thing as A to the power of half, but more importantly, it's the same thing as the log of the square root of A. Log of 1 over B, that guy, is the same thing as the log of 1, take away the log of B, but since log of 1 is 0, you only get that, and therefore the log of a reciprocal, that's 1 over something, is the negative of its log of that bottom term. That's very useful property. So how can we use this to maybe simplify some logs or to eventually calculate them? So here's one. The log to base 10 of 10 cubed. Now typically I would just call it log, but for this benefit it's going to be important. The log to base 10 of 10 cubed is going to be 3. The log to base 7 of 7 to the power of 10 is 10. The log to base -4 is -4. Do you see that a log followed by an exponential, if they use the same base, eventually cancel each other out? And so the answer is simply just going to be the missing power. And the reason why this works is that the logarithmic function and the equivalent based exponential function are essentially inverse functions of each other. So it's a bit like someone saying the square root of 5 squared is 5, right? The square root of 1,000,000 squared is 1,000,000. The cube root of 7 cubed is 7. That's the kind of thing that's going on here. If you have 2 things that are inverses of each other and you perform both processes one after the other, then the answer is simply just going to be, in this case, the missing power. Another way you can use properties of logs is you might get something like this. The log to base 2 of 4 plus the log to base 2 of 8. And you're going to eventually simplify this to 1 log. Well, it's a log of 4 times 8. That's the log of 32. Now, I would like to know what log to base 2 of 32 is, so I'm just going to call it x. So I'm going to have 2 to the power of x is 32. Now, all I'm doing from this line to here is changing from logarithmic form to exponential. And this particular one's a bit messy because, you know, you could basically just check and guess. Is 2 cubed 32 is 2 to the power of 4, 32 is 2 to the power of 10, 32, which would work. Or you could do it this way. Can you just go 2, 4, 8, 16, 32? And so if 2 to the power of x is 2 to the power of 5, then x is 5. Which means that the answer to this thing is 5. Suppose you got log to base 3 of 9, take away the log to base 3 of 81. And you've been asked to find what the exact value of this would be. Well, since it's a subtraction, you can go 9 over 81, which gives you the log to base 3 of 1/9. Now, I don't know what that's equal to, so I'll call it x. So 3 to the power of x is a 9. Now, if you want to solve this, it's essentially an exponential equation. The thing that's going to cause you trouble is that this needs to be written as a power of 3. Well, I know that 9 is 3 squared. I know that a reciprocal, 1 over 3 squared, is 3 to the negative 2. Bingo. X is negative 2. That makes this guy negative 2. Now, one of the skill building exercises that we're going to deal with are simplifying, or I should say expanding logs, number 3, or combining logs. So if you get an expression and they ask you to expand it, what they're really saying is, here is a single log, and we'd like you to break it into its individual pieces, right? We'd like you to expand it, like make it, show me the components it's made from. Now, I'm going to hopefully find my 3 laws of logs paper, because I'm going to be using them a lot. Here we go. So this is what I'm going to do. I'm going to say, okay, what you got? You got this guy times that guy divided by that guy. So the first thing I would do is say the log of x cubed plus the log of y to the 4, because these are being multiplied, and you're dividing by that guy, so take away the log of z cubed. So that's me using combinations of rule 1 and 2. Now that's good, but not perfect, because the log of x cubed can now be written as 3 times the log of x. The log of y to the 4 can be written as 4 times the log of y. Take away 3 times the log of z. And we would say this is the expanded version of that one. Now you could get something like this: a squared, b cubed, square root of c over d squared. Well, let's put another one, e d squared. So it's going to be log of a squared plus the log of b cubed plus the log of the square root of c. So far, so good. Now, there's an e in the bottom, that means you're dividing by e, and there's a d squared in the bottom, which means you're also dividing by that. So when you divide, you subtract a log. So minus the log of e, and this is going to be really crushed, minus the log of d squared. Now, each of these, we can now use the third law of logs. So an a squared gets you 2 log a. And b cubed gets you 3 log b. The square root of c, that's a little bit tricky. I'm going to use this result here. The square root of a log is half its log. A cube root would be a third of its log. Now, there isn't anything else that can be done to this one, but the guy at the end can be written as 2 log d. And now we're finished. And you could get this fella. Now you have to kind of break this apart, right? But we have to be careful about what is, the order we do it and what's going to be done to them. So I'm looking at this, and the first thing I'm going to do is just call it a half of the log of all the pieces that are inside the square root. That's all I'm going to do. Take away, because it's being divided, the log of the bottom. That's good. Now, this is a log of 3 things multiplied. So the half gets used by all of them. So it's a log of x squared plus the log of y to the 4 plus the log of z cubed. Take away 2 log w's. Move over here. I think I need a little bit more room. Each of these can be broken down a little bit further. So 2 log x, 4 log y, 3 log z. Take away 2 log w's. Well, now I'm going to distribute the half. Well, a half times 2 just gets me log x. A half times this gets me 2 log y's. A half times this gets me 3 halves log z. And this guy has nothing to do with that half, so he's still take away 2 log w's. It's us basically breaking apart, right? Expanding, as they call it, various and quite messy log functions. So let's have a little look at some of these examples. Right. Well, I'll just nip over and show you a couple of homework questions just to show you that there's little twists. That's not what I wanted. Try that again. There we are. Well, in question 17, you're given the log to base 3 of 4x. Well, that's 2 guys multiplied together, so that's going to be the log to base 3 of 4 plus the log to base 3 of x, and that's as good as that's going to get. And you can imagine that one breaking apart, actually. If you look, you can see some of these answers, which I prefer not you to see. And pick some. Oops. Excuse me. Okay, now here's version one of your homework questions. It's that guy. So that's going to be written down as a half, oops, the natural log of ABC. So it's the square root of all of it. So you get half the log of all of it. And then that half gets distributed. So it's a log, natural log of A, natural log of B, plus natural log of C. I kind of like that version. I hope WebAssign takes it. But if it doesn't, then expanding a little bit further into 3 pieces will definitely work. And that is essentially that one. Yeah. Just having a quick scan to make sure there's nothing particularly sneaky. Oh, this one's a little bit weird. So suppose I had the log of y cubed over the square root of 9x. Well, it's a thing on the top, a thing on the bottom. So the first thing I would do would take care of that. So it's log of y cubed, take away the log of the square root of 9x. Now the first piece gets you 3 log y. This piece here, the square root thing, kicks over and becomes a half the log of 9x because both are inside the square root. This piece here is finished, so I just rewrite it. This is a half of a log of 9 plus a log of x. This would be 3 times the log of y minus a half log of 9 minus a half log of x. Now, if it was a cube root, you'd get a third. Fourth root, you get a quarter. Now, let's show you things that people want to do because it seems reasonable, but it's not a good idea. Suppose I had the square root of that guy over that guy. And we're being asked to expand it. Well, I would start with the guy on the top. Take away x squared plus 1 cubed, and also take away the log of 2x plus 1. Now, some people think that you can simplify. Okay. But you can't. Not in the usual sense. They think you can call it x add 2. No. The best you can do is pull out plus 1. And this poor guy at the end is as simple as he's ever going to get. You can't do any more to that. These are being added. If it was 4x squared, I could, break it apart a little bit more and use row 1, but it's not. This is as good as that's going to get. This is as good as that's going to get. That's everybody finished. There is nothing else to see in that particular question. It's kind of finished. So let's look at the opposite direction. Suppose you have been given an expression made multiples of them, and you're being asked to combine them into a single log. So it's really what we just did, but in reverse. So an example of that would be, suppose I said to you, let's look at that. Suppose I said to you, I would like to know what the log of 3 plus the log of x take away 3 times the log of y. What that would look like if you combined it into a single log. Well, a log plus a log you add them. This guy here is just a log of x cubed. So now I've got a log of 3x, take away a log of y cubed. I said x cubed by mistake a moment ago. It's the log of y cubed. Well, a log subtract a log means that you divide. Okay. And that's your answer, the combined log. Suppose I gave you 2 log of x minus 1 minus 3 times the log of x plus 2 times the log of x squared plus 1. Well, I would take care of the multiples first. So call this guy x minus 1 squared. Call this guy the log of x cubed. Call this guy the log of x squared plus 1 squared. A log, take away a log, add a log. So what do we get? Well, we begin with x minus 1 squared. Take away a log divides. Adding a log means you multiply. So notice that that is a package. This is a package. And although there's nothing written there, there's technically a plus there. This is a package. If you're a plus, you go on the top. If you're a subtract, you belong on the bottom. That's the quickest way to keep track of these guys. And that's your answer. So let me look at some examples. Right. Okay. Just checking that I hadn't missed any. But there is something I haven't mentioned. You notice I keep using logs all the time, but technically, as long as the base is the same, the process is the same. So if this was log to base 7, all of them, then this would be log to base 7, this would be log to base 7, and the answer would be log to base 7. So actually, the base is irrelevant. It doesn't change anything as long as all the pieces have the same base. So this guy here could be log 10, could be log 2, could be log 44.1. All you would end up with when you were finished would be the log to the base 44.1 of the exact same expression. So let's move on. To using the laws of logs to evaluate an expression. So let's say the log to base 3 of 6 plus log to base 3 of 12. And I'd like to know what that is equal to. May have to do a little bit more. Take away log to base 2 of... Trying to make one on the fly is a little bit tricky. So that's one of the problems. And that should be base 3, of course. This question is impossible. So it's a log to base 3 of 6, right, times 12 divided by 8. So it's a log to base 3 of 72 divided by 8, which is a log of 9. Not working would look like. Then I'll show you a slightly different approach to get to the same result. You get x. That's 3 to the power of x then. 3 to the power of x equals 9. 9 is 3 squared, so that means x equals 2. Therefore, we've combined these logs and calculated their exact value as 2. Slightly different approach to get the same result. Right? All I do is I call this 9 as 3 squared. And then, you know, we have that rule that a log to base 3 of 3 to the power of something just gives you the power, and there's your 2. It's a little bit quicker. And that is essentially how you can use the law of logs to evaluate an expression. Let's see if we can. Let's see if we can then move on then to our next subtopic. I can find the right piece of paper. You can bear with me for a little while. I'm going to keep that. Covered quite a lot. We've done all these guys. Now let's use a technique that we've already used before, which is essentially using the laws of logs to evaluate an expression. But sorry, I should say using the change of base to evaluate an expression in a log. So suppose I wanted to say 2 decimal places, that guy. It wouldn't really be possible to get an exact value for that. It won't be a number like 3 or a half or -2, just won't be. But we can still get the answer by using the change in base. And these two guys belong on your calculator. And so let's see if I can make that happen. And we have log of 9 divided by log of 7. Log of 9 divided by the log of 7. And to 2 decimal places, that's 1.13. Now, you know that there are 2 versions of the change in base formula. The second one is the natural log of 9 over the natural log of 7. So let's do that one. Natural log of 9 divided by natural log of 7. And the answer I got exactly what you'd expect, because it's the same thing, 1.12. So if you want to find the value and a rounded off value at least, you can do that. So we're pretty much coming to the end of this one section. And this week's homework is going to be, in the test, is going to be very limited. And the reason for that is that this is week 8, is going to be the week in which your midterm 2, your second and final midterm, appears. So you want to make sure that you've got the time to prepare for it. So I've reduced the topics that we covered during this week to accommodate that. So hopefully you'll be prepared and you'll have learned from the last time any shortcomings that you may have had, like preparing for the midterm or making sure you've got enough time to complete it and upload your work. And that would be really good if you could upload it the way it should be into Canvas. It just makes my life 10 times easier. Now, the application question that we've got is really just one. And they've got a guy called Ebbinghaus law of forgetting. States that the task is learned as a performance level P0. So that's a performance level. Then after time t, the performance level. So P0 is the performance level that you learnt within it. So let's say you're, I don't know, memorizing 100 French words, vocabulary. And You got them in your head, but time goes by. And if you don't use it, you lose it. Maybe time is 4 days or 40 days. Obviously, 40 days, you've probably forgotten more of them in 4 days. Most of them should still be in your head by that time. P is the performance level. Now, at the end of T, in months, wow, that really will tax your memory. What could you remember in 4 months or 2 months or 6 months or 12 months or a whole year? And the formula that tells you that the log, to base 10, of your performance level after T months is the same thing as the log of your performance level at the start when you've reached your best recovery. Take away C, the log of T plus 1. So there is the horrible log function. Now, you're told in this story to try and find out what P is equal to. So we're trying to find what that performance level P is. When T is, let's see, 2 years. So that means what, 24 months. Okay. And P naught is your initial performance level. So you got 75 in your vocabulary, French vocabulary test. So you remembered 75 out of 100 words. And you're told in this story that C is 0.3. I'm assuming that C is some measure of a particular person's ability to hold on to information. So some people have got exceptionally strong memories, right? If you tell them something and ask them 6 months later, they still remember it, right? I, on the other hand, can hardly remember what I got for dinner yesterday. So I'm assuming that C is big for people who have bad memories, as I do, and C is like 0.05 for people who've got like photographic memories. So we are going to find P after 24 months, where the performance level started off as 75, and C, I'll call it the forgetful factor, is 0.3. So I'll begin by rewriting this formula that we've been given. Now I'm going to have the log of P is going to be the log of 75, take away 0.3 times the log of 24 add 1 is 25. And so I'm going to find the log of P is going to be this guy, take away that guy. I'm making no attempt to make that a whole number or combine it. I'm just going straight into my calculator. So even if you might not be able to see me doing it, right now I'm typing in the log of 75, take away 0.3 times the log of 25. And I am looking at 1.4557. That's the 4 decimal places. Now, if you're not careful, what you're tempted to do now is just to say, oh, I got the answer. It's 1.4557. That's going to be a performance level, which would mean, well, although it's not true, it would mean, well, they can remember 1.5 words in the vocabulary test. No, we're wanting to know P. All we know right now is the log of P. And log is log to base 10. So 10 to the power of 1.4557 is P. And that's the calculation that will tell me what the performance level after 2 years is. So let's do it on my calculator. 10 to the power of 1.4557 And remember to hit enter. And I get 28.6 to 1 decimal place. And to the nearest whole number, that would be 29, which is what the homework asks you for, at least for my version of that question. And that is the end of week 8. So